Hi everybody, welcome. Thanks for coming. My name is Eric, and if you are here to learn about hacking into Kubernetes and how to prevent it, you're in the right place. If you're not, stay anyway. I am a developer advocate at Snyk. I'm not going to be talking about Snyk much at all, really at all. But just to give you a background of where I'm coming from, I am a developer by history. I did about 20 years of software development in the North Texas area and multiple different travel companies like American Airlines and stuff like that. The last decade or so I've been more in the build and automation, CI/CD. That's where I got introduced to Docker back in the early days. I was a Jenkins ambassador at one time, and I'm a Docker captain now. I have the the normal CK star certifications you would think of when you think of these kinds of Kubernetes talks. I'd like to get a feel from my room. How many of you are new to Kubernetes? Okay, cool. So we got a good mix. How many would consider yourself a developer background? And operations or SRE, something else? Man, awesome, cool. Well, given that I have a developer background, you're going to be seeing me come at this from that point of view. And what we're going to really hit on today is we're going to take a look at how exploits happen in Kubernetes, especially when dealing with how a hacker might get into your cluster and get admin control out of it, right? And most exploits, attacks happen by a combination of several things. Often it starts with an application vulnerability or a vulnerability maybe in a dependency of that application, whether it be a library or an operating system package or something they can get a latch on, combined with a misconfiguration, whether that be something you made a mistake on or you just took a default that you thought was safe and might not be. So that's what we're going to take a look at an example. This is a contrived example. It's for this 45 minutes. I can't set up a full-on Log4Shell or something like that, but it is plausible a way that this attack could happen. This is an interactive workshop if you want to try this after the fact. We don't have time to do this together and mentor you through this today, but I'll put that back up on the screen later too. But there is a GitHub repository that you can go to, and there's a workshop directory in there that has markdown pages that we're going to walk through today, and you can go do this after the fact if you want to play with it. So that's about all the slides I've got. We're going to get right into this demo. To set the scene, oh, by the way, that's going to happen a lot for the next couple of minutes. So before I start the demo, yeah, this is the, if you didn't see all the news, they're testing a new nationwide alert system. So we'll let that calm down. Those of you watching the recording, yep, there's mine. Come on, hush. Fun. Okay, are we good? Dang, it was early by a couple minutes according to my watch. So that's out of the way, hopefully. Setting the scene, putting yourself in the foot of, or in the shoes of a kind of a hacker. Let's say we've been looking around the internet, poking around, looking for vulnerable applications, and we have found one at this point in the game. We've found an application that has a remote code execution exploit. Insert your favorite one there, but something that would give you the ability to run commands on it. See? Somebody found it. There's another exploit right there. It's going. The alarms are going off. For those who can't hear on the mic, this alert's still going off in the room. So, oops, that's not the slide I want. So, first things first, if you do follow along and do this afterwards, the big warning here is important. This is the front page of that workshop. Anything you get from Snyk's repositories that have the word goof in them, do not deploy this anywhere you care about. There are a lot of vulnerabilities in these repositories, and if you put this somewhere that has access by anybody else, they could potentially get in and do nasty things in your environments. So you have been warned. Sorry, the alarms have taken me out of my groove. So I'm going to skip the setup here because I've already done that. So what we have, just in a nutshell, is we have a kind cluster because I want to do everything local. I didn't want to run anything across the network because, we're conferences. I'm using kind because it is a kubeadm compliant cluster. If you're not familiar with it, it is Kubernetes in Docker. It is an implementation of Kubernetes running inside Docker containers, or containerd containers, actually. And it is a stock deployment. You can put your own kind of CNIs on it. You can do all sorts of stuff, multi-cluster. So we have a 2-node cluster running with, I think I have Calico installed on this one, but whatever, just something that could do normal CNI things. That's already set up and my application is already out there. So let's take a look at examining the vulnerability. So the front page of this wonderful app has this, somebody has found this page called Web Admin. And if I were to add, I'll grow the font here in a second. So I just added a CMD equals, and I put env in there for the argument. So it ran env on the remote system. This is literally how a lot of remote code execution looks to a hacker. You get in, and you can start running things through a web portal or through some kind of reverse shell coming out to your own terminal. I ran env, though, because I want to investigate. I want to see where I am, what I'm dealing with as far as this remote system. And by looking at this, I can see it looks like we're in Kubernetes, because there's a lot of Kubernetes named. Another alarm went off. Another Kubernetes, or a bunch of Kubernetes named variables. And some interesting ones to look at when we're in here, we can see that there is this thing called web admin service port equals 5000. And take note of that. That probably means we have a Kubernetes service in front of us that is hosting on that port. Kubernetes, where is it? Again, this alarm has taken me out of my groove. Here we go, Kubernetes service host. This, to the pod, is the API endpoint for the control plane. So if I can start tickling at that, I might be able to start finding things out about my cluster. And additionally, we'll get back to other things that are in here. So if we go back to the workshop, and I'm going to be copying things right out of here so that you can, if you're following along later and you look at the recording, you can kind of see where I am in here. So we did this, we did the env. Other things we could do, I could look at what's my host name, so I've got just hostname-i, so my IP address. So I now know, okay, my node is at pod IP blah, blah, blah at 135. And next thing, we're going to take a spot. So as we go through this, we have these slides that just kind of give us a level set of what we've discovered so far and where we're going. What we know is we have something on port 80 listening. That once I got into it and found this exploit, we've discovered the pod IP address. There's probably a service in front of it listening on, this thing is listening on 5000 behind that service. And we know the internal IP of the control plane for this Kubernetes cluster. And I have what we call the timeline of doom. And this is basically starting out on the left, introducing that we found this app vuln, and as we go to the right towards getting admin on this cluster, we'll see the steps going along. So, next step, let's start poking around and see what we can find in here. So, on Kubernetes, not to give away, what am I going to look up here? You have service accounts. And the screen went black. Oh, locked my screen. By default, when you deploy a pod in Kubernetes, when you deploy a service account, when you create a service account in Kubernetes and deploy a pod into it, there is a credential that is given to that pod to communicate with the control plane. Unless you set that, there's an argument you can set to false, this will be there. And this is a credential. This is something that if your application needs to talk to Kubernetes and do things with it, it's important to have, and you have to have that. If you've got a business application, like this might be, probably don't need this, and you should be turning that off. And we'll talk about that when we get to mitigation sections. But we have this token. I'm going to skip forward because we have limited time today. I want to see also if I've got some tooling available to me. So I'm going to try to run a curl command. And so I ran a curl, oops, if I go to the right tab, to just try to go to Google. And sure enough, I have curl at my disposal. So curl is in the file system of this and in the path of container. And it was able to get out, and I got a 301 redirect. So I have network access out to the internet. That's good to know. So the next, we're going to put those things together, and this is really long, and we're going to use curl along with that token we just found on the file system and the CA that's sitting next to it. And if you're curious, that's under var run secrets, Kubernetes IO, service account, token, and CA. We're going to set up a authorization bearer for that, and we're going to hit that IP address from the first thing we found, that Kubernetes port. And I'm fast forwarding how this would really happen. I would probably be poking away at it, seeing what can I get. I'm going to get a lot of denials because I don't have access to it, hopefully. But for some reason, these people have left something open here, and in this case, it was the endpoints API. And if I look through here, I can see, oh, look, there's the Kube API server, and if I was not running in kind, that would be the IP address on the local network, the host IP, outside of the pod that could get to that API endpoint. Now, we're running in kind, which wraps things in a Docker layer kind of setup, so I'm going to be using localhost for this demonstration. But if you had deployed a kubeadm deployment onto a couple of VMs in your home lab or something, that should be the IP address that is the public-facing one that the Kube API is bound to. So that's good information. And my goal here is that using this little web interface is kind of cumbersome. So I want to get to where I can actually, from an outside shell, use a tool like kubectl and start accessing this cluster directly. And that's why I wanted to know that kind of information. So what we know now, we have this, what we already knew, what we've learned is there's that variable. Let me grow that font. The auto mount service account token setting. This is a variable on, or a value property on the service account is set to true, or it's defaulted. The default for it is true. That's unfortunate. I really wish it wasn't, but it is. And because of that, any pod started that doesn't override that itself is going to get that token, and that's true in this case. So we found the service account token, and we were able to use it to tickle the cluster's API server and find an open thing on it. So we know it's a good credential. And we happen to find out what the external IP of the API server is. So in our timeline of doom, we've added a couple more lines as we go to the right, found the token, and found out what it gives us a little bit of access. So next, we're going to start fact-finding in this cluster. I want to get in here and look at some more things. And like I said, I want to do this locally, because it's kind of a pain in the butt to keep using this web interface. So I've got a simple helper script in here that will create a kube config for a given token and host. So I'm going to go back to the tab that had that token and copy the whole thing. And I'm going to come out to my shell. I'm going to delete a file that I have from testing this out this morning. And I'm going to run this. I'm going to source it actually. Set up kube config. I'm going to paste the token in there. And like I said, this is a local host because I'm running kind. So I'm going to just put that in for the API. Okay. And there we go. So now if I do, I have K as kubectl because I alias it because I'm too lazy to type. If I do a git pods, forbidden. Okay. So I tried to get pods in the default namespace, and I was not allowed to. That's good. That means that this service account isn't like, we're not in default, and we're not exposing that to the world, but you can see there's a little bit of leakage here in the error that's telling me that the user system service account secure web admin cannot list resources. It doesn't have the git on pods in the API group. But that tells me what namespace this is in. It's a namespace named secure. Now, namespaces are not security boundaries. By naming your namespace secure will not make your cluster secure or your app. But I now know that that's the name of the namespace. So let's try the same command in the secure namespace. And sure enough, there is a pod with one container. That must be my vulnerable application that I have been messing with. That's interesting to know. So let me make sure I'm not going too far off track here. So we've found all that out. What else? Oh yeah, let's take a look at what else I can do with this. So I'm going to use a auth can I and list my privileges. So in the default namespace, you can see there's endpoints. For whatever reason, they opened endpoints up here, and I got that. Not much else. Just boilerplate things that really don't help me much. But let's try that in secure namespace. And sure enough, it's wrapping, kind of hard to see. But if you look, I have to stay next to this line. I can't go over here because the camera loses me. So over there, it's cutting it off a little bit. But you can see star.star under resources. And then on the far right, you can see under verbs, the beginning of a long list of verbs. This credential has basically everything I need, God control, RBAC related, in the secure named namespace. So I can start, that's handy, that's good to know. That tells me I can probably, well, it's excellent actually. Well, we'll get to that in the next step, but what we found out now is that the token we gathered has limited access in default, but it has broad access in secure. So our little graph starts filling out, and our timeline of Dune, we can add that it gives, this role it probably has more permissions than it needs. This is a very common thing that as a developer I've done. You create a role, a service account, and you just say, I need to do whatever I want in my namespace because it's my namespace, so give me all the verbs. Not always the best practice because, again, you want to minimize what's, well, we'll see. So go to the next step. So we want to get a beachhead on this cluster. We want to get in here and start running our own things if we can. So like I said, we know about this pod, so let's see if we can exec into it. So let's go ahead and do the get pods again, and I'm going to do k exec with a terminal, the web admin, come on autocomplete. Oh, duh, namespace secure. There we go, and we see if there's bash. Hey, we have bash in there, yay. So I'm now in the same container that was running the I'm in the same container that's running the vulnerable application. If I do a PS, I can see, oh, there's the Python app. It's a Python. That's cool. Whatever. But what I want to do is start seeing what I can do in here, right? So, well, the first thing I want to see is I did who am I? I'm not root. That's a good sign. They actually thought about that, but sudo is not found, so can't do that. So let's see if I've got a read-write file system. Touch, foo, yeah. Yes, so I'm able to write files. So they didn't turn on the read-only file system. This is a mutable container. That's good, so I can bring down things if I needed to. This is interesting, but because I can't become root in this container and I'm not in privileged, doesn't do me a lot of good. So I'm gonna jump out of here, and I've got another simple pod definition I'm going to try to run that just starts up an Alpine sleeping image just to see, because Alpine, like most official images, starts with a user of root, because that's what they all do. And then you're supposed to switch to your own user like they did in their app. But I just want to see if I can run a root container in here, a root-owned container. So let's do k apply into the secure namespace. Demo URLs, what did I call that? Root pod. Checking my time. And that shouldn't have worked. Hold on a second. Did I unset my? I think I might have accidentally done something. Sorry, just a second. I think I went back to my kind owner credential because I exited out of my source. Root pod. What in the world? Okay, well that should not have worked, but that's interesting that it did. So let's play with this. K IT secure. Oh, that's why. K delete pod and secure root pod. That's why I tried to delete it in the wrong namespace. So what has happened is I think I'm using my kind owner password or credential. So I'm going to delete that out, and I'm going to go ahead and just set. Come on, finish. Live demo is always fun. This is why other people I know in this room record their demos and show them either scripted or recorded. There we go. Now, we're going to try this again.
Okay, imagine that failed. I don't have time to debug this right now. That's amazing. So what that should have done, I'll have to take a look at what I've screwed up, is if we go back to my screenshots, we should have seen this forbidden. And we should have seen that it violates pod security restricted latest. I bet you I know what I did. Allow privilege escalation, blah, 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 blah. So what we're seeing, what we should have been seeing is that that they have implemented pod security admission. If you follow Kubernetes, pod security policies was the old way of doing enforcement of security context. And it was deprecated and finally removed last fall in 1.25. And pod security admission, for the most part, is the replacement for it. It doesn't do everything PSP did, but you can set a namespace up with a baseline. There's 3 different classes, but baseline is what should be set up for. And I'm thinking what I did is I didn't push my change to make that the case. So imagine we saw that error, and I will fix that with a pull request right after this call is done, or this demo is done. So we can't run a root. The idea being you can't run a root container in that case. It also restricts privileges. So let's see, let's go into, just show you this. This is another container of my own that I'd like to deploy that doesn't run as root. So it runs as a user 999. And this would fail as well because I'm not explicitly calling out all those things we saw in the PSA restriction. So you need to have, and I've got a version of this, you need to have a security context setting to set your run as non-root true, and you need allow privilege escalation to false, as well as dropping capabilities, and also a seccomp profile. All those things have to be present if you've enabled PSA at baseline level. There's also a very restrictive version of PSA, but that's like kind of the best practice, if you will, that the open source community in Kubernetes has come up with. So by having all of those things in there, it eliminates a lot of easy hacks you could do. The main one being the allow privilege escalation. Allow privilege escalation, so we all know privilege, that's where you get root access to devices on the host. That's by default false. But allow privilege escalation by default in a pod is true, and that allows you to run a SUID bit binary like sudo. This image has sudo in it. That was a great enhancement that PSA added to make that not be true anymore. So you have to explicitly call that out as false. And I'm going to, because my demo flaked out on me there, I'm going to look at one real quick thing. You see the inside, the sausage is made here for a second. And I'm guessing that my namespace, yeah, I didn't, I've got my old PSP version of it in there. That's why this didn't apply. So you're just going to have to roll with me on this. I apologize. So what we're going to do is we're going to act like I couldn't run a privileged container or root one because that's set up. And I'm going to deploy the one I just showed you with all those restrictions placed in it. Apply -f or -n secure. The demo YAMLs non-root. Thank you. That's why paired programming works. And we're going to go for the non-root baseline. There we go. So sneaky pod has just been created. So again, sorry for herky-jerkiness there, but we've now deployed a pod with restrictions on it, but we've deployed our own image and pod into somebody else's cluster. So I'm going to exec into that. And you can see it says, hey, you should try to do sudo. That's not going to work, though, because of that setting being turned on, the not allowing privilege escalation. So at this point, what I want to do is, I'm going to scroll down here. I'm going to pick up here because I'm under 20 minutes now. So because of the restrictions that should have been in place, were in place, I couldn't do that. So now what I want to do is I want to go forward, and my slide still says PSP2. I want to get out of this namespace. I want to get somewhere where there is more breathing room, more ability to do things. So I'm going to bet that if developers are deploying on this cluster and they do debugging of things, they might be deploying this app in other namespaces. And I'm going to start poking around and see if I can find another copy of a vulnerable version of this app and see what it looks like. So I know in this, there's my IP address. So I know I'm at .140 in my sneaky pod, and I know from, find the tab it's in, my pod that I initially exploited is at 135. So I'm kind of getting a lay of the land here. So what I want to find is where else might one be running. And there's a handy tool called Nmap to do this. Now, Nmap has multiple modes. If I had root access, I could run it in a mode that does SYN. I'm not a TCP expert, but it is scanning on the SYN packets, which is much more stealthy. But I don't have root, but I can run it in this TCP Connect version. And what it's going to do, I'm going to copy this, and I need to make a quick edit while it's running. So that -ST at the front, that says scan by doing TCP connects for anything on port 5000 across this CIDR. And I'm going to change this to, I guess it's 24, so it really doesn't matter, but I'm going to run that. So that's now hopefully alerting you somewhere in your network that somebody is trying to connect things, or logs are opening up on other apps and you're going to get notified. But I'm in your network and I'm poking around now. And sure enough, it found two IP addresses. 135 and 136 are both listening on port 5000. If you recall from a second ago, we looked at this tab, and we saw that, let me close some of these. 135 is the original one, so we don't care about that. We care about 136. What is 136? So I want to see if I can get at that one and find out where it is. So the next thing I'm going to do is use another nice little tool. There's a comment in here about if you have root, you could use SS, and it would be less intrusive to find that out. So this also tells me that you aren't running network policies, or you have very lax network policies in your Kubernetes deployment. Because if I was able to start hitting all sorts of different ports and finding things, firewalling is not really happening, or not a very good job of it. But I'm going to use socat, which is socketcat, to, first I'll copy it from here. And copy it, I'll have to edit that IP. I'm going to fire this up in my sneaky pod, and I'm going to change this to 136. So now, if you're not familiar with socat, what it has done is it is listening now on this machine at port 5001. And any traffic that comes into this machine at 5001, it's going to shunt it out to that other IP we saw at its port 5000. So in another tab, I will export, not editor, kubeconfig equals demo kubeconfig. So here I am using the same credential in another tab, and I'm going to simply start up a port forward into my sneaky pod. So there we go. So now we're listening on my local host at 5001 and sending that traffic to the pod that I have running in the cluster. And so if I hit localhost 5001, and sure enough, there's another copy of the app. Oh, hey, somebody's fired up another copy of the app. Is it vulnerable? CMD equals who am I? Sure is. So there's another copy of the app running somewhere else that's vulnerable. So let's see if we can get at that. And of course, since we have access to run commands in it right now, we're going to go ahead and let's get the service account token for that one. I'm going to copy that, and I'm simply just going to come back over here. Now that I have that, I really don't care about my tunneling, because I want to go after that one now. So I'm going to come out of that, and I'm going to edit this kubeconfig I've created. I'm simply going to make a copy of that line, and we'll come in here and paste that token in here. And now we'll do k get pod. Oh, look at that. I can see pods running. In fact, one that I was using to test with earlier, so I'm going to delete that real quick. Pod delete, k delete pod, non-root priv. Okay, so we can see there's that other copy of web admin. And we know this is not the one we're looking at before because we're in the default namespace now. So we're in the default namespace now, which is fun. The thing about default namespace is it's just another namespace, but it's always there. And it often is forgotten. People have namespaces for their apps. Somebody is late to get the alert. They have namespaces for these apps, and they use them all the time. And if your cluster ops did not put restrictions on default, it might have the default settings. So I've edited that. We're going to go in here, and let's see what I can do in the default namespace. Oh, look at that wildcard on all those verbs, same as we had in the other. So this is basically, nobody's set up RBAC on the default service account in the cluster. So that's fun. So I'm going to try to put in my own pod that actually does run privileged. So we've got non-root priv. So I'm going to try to deploy this version of the same pod that runs in privileged mode, because apparently we're in a default state, and I'm betting they didn't apply PSA. So let's do k apply f demos non-root priv, and there it is. So let's see. All right. Now we'll do k exec it into non-root priv, run bash sudo su. Oops. Not sudo su. What am I doing? Sudo -u. What am I doing wrong? I'm panicking because I'm on stage. I've forgotten my sudo commands. Right? Yeah. No. I can just do that. That works. Sorry. I'm getting back out of it, though. If you look at what I can see when I'm not root, I've got things running. There's a GoTTY that's in my sneaky pod that I could use. But if I sudo in, it's just -u, isn't it? No, it's not. I'll just do that. It doesn't have my path, but whatever. But now, oh, I still can only see that stuff. But what else was in that pod? There was also a host mount. Now I'm on the host. So now I am effectively root on the node that this is running on, which gives me all sorts of options to do things. Now, what is on root on a server? So I'm skipping through what we found out because I'm walking through this with you anyway. So what we know now is RBAC is wide open for the default service account because I shouldn't have been able to do any of that. But now let's see how we can get from a node to a cluster. Now I've actually, because I was messing with this earlier, I've started this on the kube control plane pod, but this could be running on any of the pods in the cluster. What I'm going to go for is, now that I have the root file system, I'm going to cd into etc Kubernetes, and there's the kubelets conf. So let's export kube config equals that. kubectl get pods in the kube system namespace. So now I have kube system access. Now one thing, I'll skip over this for time's sake. I won't skip over this. kubectl get nodes, so I can see what nodes I have as well. I could try to run a pod. That will fail. Kubelet does not have, the kubelets token does not have the rights to start pods via the API server, because it never would need to do that. It starts them directly with the container runtime. So that is just an interesting side note. What I can do, though, is get at things in kube system. So, or I can try to. Can't get secrets, though. That's forbidden. That's good. That's good that they don't allow the kubelet to get at all the secrets. But there are other things that can. So what I want to see is we see that this is an etcd cluster because it's just a kubeadm created cluster, so it's running etcd right on the control plane. I want to know a little bit more about etcd, so I'm going to describe it. And I can see all sorts of information about where its keys are on its node, what node it's running on, and all sorts of other good information about the etcd server. And what's in etcd? Everything. So skipping forward, I have another file out here called etcd client. It's going to pull down the standard Kate's etcd image, and I've already pre-populated this with all the values you just saw in that describe. So it's going to pull in, it's going to start up on the kind control plane node. It's going to mount in the host directory that has the PKI etcd directory, and it's going to pull in all of the environmental variables for the certificates and credentials for connecting to etcd. So we'll go ahead and fire that up. K apply dash F. Let me get out of, I need to get out of this. We're going to run this from outside. K apply dash F, demo etcd client. K get pod. That's running. So let's make sure that it's working. I got 7 minutes. Oh man, we're on the wire. So we've applied it. I'm going to do a simple exec, and I'm going to do a member list just to see if I can see if I'm getting a good, valid handshake. And sure enough, I am. I was able to connect to etcd and get a response back from it. Didn't get a credential error or anything like that. So let's see what secrets I can see, because that's obviously what you would want as a hacker going into somebody's etcd. I can only see 2. That's not fun. This tells me that this cluster, I should have known this from other things, but this cluster is newer than 1.23 or 4. I can't remember. They changed the setting to stop automatically creating Kubernetes searchable secrets for a lot of the internal controllers, so their service accounts. So what I want to do is go back to my settings here. There's one I need that I can't see, but I'd like to, I'll show you how to do this. I want to go in here and I want to turn that off, that feature, so that all these secrets start showing up again. And I'm going to do that by going back into my sneaky pod, which I have running accidentally on the control plane, and I'm going to edit the YAML in there for the controller. So let's just do it. So okay, exec it into the non-root priv. Give me bash. Go back into here, chroot /chroot. I'm going to etcd, or sorry, etc kubernetes manifests. These are the static pods for the cluster because I'm on the control plane. And I'm going to copy, just in case I screw it up, the controller manager. I'm going to go put it out in temp just to have a copy of it. And now I'm going to edit it. And there's all the flags we feed the controller manager. And I'm just going to add one in here. And I'm going to copy it because it's long. So I'm setting the legacy service account token no auto generation equals flag to false. This by default in 120, I guess I think it's 124 is set to true. So we're going to add that. And now immediately, if I go over to another shell, if I do a git, actually let's do it from here. Kubectl git pods in the kube system. I don't have my kube config set, do I? No. Export. So we're waiting for it to fire back up now. So whenever you modify a static pod, it takes a moment to obviously restart. So it's 0 of 1, 1 of 1, good. So we're going to come back out of here, and let's do this again. We're starting to see more and more secrets starting created as that controller manager comes up. There's one in particular I'm looking for. That is the cluster role aggregation controller token. And I'm going to copy this big long line all the way to there, paste, and that is HN541. Oh, thank you. That's the token for the cluster aggregation controller. What can that do? Edit the demo kubeconfig again. Comment that one out and paste that in. And we'll do a can I on it. So a lot of boilerplate in there, but you can see the cluster roles has a bunch of privileges on it. One of them is escalate. So let's edit this. So you can see here's the RBAC for the cluster role aggregation controller. It's got all those things in there. I would like that to be everything, please. Save, quit out of that. Did I? Thank you. Well, did it fix it for me? Wow, hey, good on you, Kubernetes. Thanks for helping me hack you. So now if we do the auth can I list again, wildcard, verbs wildcard. Because we're down to 2.5 minutes according to the clock, I'm just going to jump forward and go back to my slides, because at that point, that is game over. I now am admin in the cluster. Once you have all those verbs, I can do everything that I could have done at the beginning when I was accidentally as my kind admin. I can now do this to that cluster not being that. So I'm admin on the cluster. So how could we have prevented this? In 2 minutes, a lot of things. Number one is keep on the latest version of Kubernetes. Because if I was on Kubernetes 1.27, this is 126, that last thing I was, what was it? They changed that flag that I set to make those secrets appear is now locked. You can no longer turn that back on. So stay on the latest version of Kubernetes if you can. That will help a lot. It hurts me in my demos because I have to keep figuring out ways around it. And I'm in SIG security, and I didn't even realize they had set that. So anyway, secondly, that RCE at the very beginning in the application, whether it was log4shell, 0-day on WebP that came out a couple weeks ago, the 0-day on curl that's being announced right now, all of those things give people the front door to start these things. Scan your application code, whatever vendor you want to use. I obviously have a favorite, but use whatever you got. Make sure you're watching for vulnerabilities in libraries that you use, operating system packages that your containers are using. Scan your Kubernetes YAML. There's a lot of scanners out there for that, for your IAC files. Make sure you're putting these things in. Don't rely on the fact that PSA will stop you. That's a great thing, but have the belt and suspenders of having your CI and your dev workstations scanning your YAML to make sure you're doing good practice. Don't trust defaults. As you see, defaults are your enemy, and a lot of times you can't rely on them a lot. Be explicit about things in your YAML. And use policies. I don't have time to get into network policies. They're not scary. They're not hard. And they will help you in a lot of things to minimize things. And then enforce all this with admission controllers. We saw PSA running things, but you should also have Kyverno or OPA Gatekeeper, something to enforce your policies. Thank you to all of these people, because a lot of this was made possible by input from all these people in this security community, including the SIGs and tags. And thank you. I made it. Apologize for the one demo flub there. But we have 12 seconds for a question. Otherwise, actually see me out in the hallway. I'll answer any questions. Thanks.